Hello everyone, I'm excited to present our paper named GaussianFormer3D, Multi-Modal Gaussian-based Semantic Occupancy Prediction with 3D Deformable Attention. In recent years, vision-based occupancy prediction becomes popular. However, these camera-only pipelines fall short in perceiving depth and geometry and are vulnerable to lighting and weather conditions, while the usage of LiDAR modality can largely alleviate these issues. On the other hand, grid-based representations are common scene representation choices due to simplicity. However, they suffer from the redundancy of empty grids. Instead, the emerging 3D Gaussians provide us with a continuous and compact scene representation. In our work, we explore to use multimodal sensor data to predict 3D Gaussians for efficient semantic occupancy prediction. We first model the scene as a set of 3D Gaussians, where each Gaussian is parameterized as a mean position, a covariance matrix, an opacity value, and a semantic logit. We first propose a voxel-to-Gaussian initialization strategy. We initialize the 3D Gaussians' means and opacities with the LiDAR voxel features. This strategy provides the Gaussians with strong geometry priors from the range sensor data, which largely improves model's convergence and performance. We further propose a LiDAR-guided 3D deformable attention mechanism to update the 3D Gaussians with LiDAR-camera features. The Gaussian queries are updated with the features sampled from a 3D space formed by LiDAR depth maps and RGB feature maps. A two-stage sampling method is further designed to aggregate LiDAR camera fusion features. The high-dimensional Gaussian queries are iteratively refined and finally decoded, voxelized to be semantic occupancy. We evaluate GaussianFormer3D on on-road new scenes dataset and off-road RELIS 3D dataset. On both scenarios, our method demonstrates superior performance, especially on small dynamic objects and large surfaces. Our method also achieves superior performance across multiple benchmarks. More importantly, our framework outperforms the state-of-the-art voxel-based methods with reduced memory consumption and enhanced efficiency. In summary, we propose a novel multimodal occupancy prediction framework which builds on 3D Gaussian representation. However, our method is still limited to fully supervised manner and requires dense occupancy labels. In the future, we hope to explore its self-supervised variant and its application in multi-robot coordination.